So I had 4 terrific years working at Grab, and worked particularly on designing and building GrabShare to begin with for the first couple of years, and then having a very long-term background in natural language processing and machine learning, I worked on language processing, particularly at Grab for a couple of years, particularly related to advertising and ads targeting as the team got more specific, but also with regard to a few other problems like translation. So I'm very, very happy to meet you all and very honored to be invited to give this talk on natural language processing for mobile users in Southeast Asia. So, quick introduction, natural language processing. I'm basically going to go through the title quickly and say what it's about. So the natural language processing part, NLP, it's become pretty big recently in the past 5 years. For many years, we felt like a bit of a niche area in technology, but I think we've become quite front and center of artificial intelligence at the moment, to the extent that we're possibly overhyped. People might think we can do more than we really can. And natural language processing goes back at least to the seminal paper by Alan Turing in 1950, Can Machines Think? Or the paper was called Computing Machinery and Intelligence. And Turing posed the question, well, do we know if a machine can really think if it can have a conversation with us? And so if we're going to start the field of natural language processing anywhere, then maybe we'll start it there. And one of the reasons I bring that up is it's easy to think, oh, natural language processing, we've been hearing about it for about 3 or 4 years. The field's probably about 3 or 4 years old. It's at least 70 years old. But for the first several decades, most of the work on natural language processing was following fairly formal logic, rule-based approaches up until about the 1990s. And this wasn't just natural language processing, this was a lot of linguistics as a whole. And it's a real general question about language. Is it something that we reason about or something that we just learn and respond to? And I think really the answer is it's some of each, and technologies built from each work in different ways and with different successes on different tasks. But after the 1990s, well, probably around the 1990s, I'm just kind of picking rough dates. Historical trends are never exact, but by around the 1990s, we were realizing that some of these rule-based approaches didn't work very well. They were easily broken, quite brittle, and empirical or statistical, machine learning-based approaches that started to be investigated in a lot more detail and preferred, partly as we had more and more language to deal with. More and more language data sets that we could work with and process. And so part of the explosion in machine learning for natural language processing goes along with the advent of the World Wide Web, particularly, that by the mid and late 90s, the amount of text you could get your hands on relatively easily had increased dramatically. And by now in 2020, we normally have more text than we know what to do with. And so a lot of empirical data-driven methods came a lot more to the forefront. And in the past few years, particularly, the leading methods in that family are particularly the neural network methods, often referred to as deep learning. Little secret, a lot of the networks we use in natural language processing to build so-called word embeddings aren't deep at all. There's only one hidden layer, but that's possibly a side issue right now. Anyway, we talk about deep learning, whether it's technically deep or not. And even if you use a shallow neural network, put deep learning on your resume. No one puts shallow learning on their resume. That one won't go down very well. And so you could easily read a lot of the literature at the moment, particularly the kind of tech press, and believe that artificial intelligence and neural networks have solved everything, and that that's all researchers do. It may be most of what academic researchers do, but in practice, having worked on a lot of production systems that are facing real users, every natural language processing system that I've worked on in production isn't purely rule-based or purely machine learned. It's always a mixture. The standard conversation you might get to for machine learning in production is you might have a researcher or a research engineer saying, hey, this model's great, it's 99% accurate. But what does that 1% look like? Because when you're publishing a paper, then 1%, that's not too bad. If that 1% is particularly bad for some reason, and users see something that is offensive, illegal, charging them the wrong amount of money, then you have to take it down right now. So you need systems that can do that, and take this particular thing down is a kind of rule. So natural language processing in production systems is always a mixture of techniques, and those mixtures can be very interesting in themselves. So that's natural language processing. Very brief introduction. Natural languaging for mobile users. So what do we mean by mobile users? Well, in particular, by nowadays, we mean users with smartphones. So the users themselves are mobile, and the device they're using is mobile. So here's some examples from Southeast Asia, particularly. We've got all the Grab drivers driving on their mopeds, motorbikes. And one of the particularly interesting things about that use case is it's one-handed. The driver is driving with their one hand on the handlebar, typing with the other hand, and that leaves them even less attention to actually pay to the phone, because the phone is a side issue. They're paying attention to the road. There's a lot of people who are using phones whilst doing other things, whilst walking around, whilst getting the MRT, mass rapid transit in Singapore, or whilst trying to get in a car and travel with someone. Or they're using phones to make orders, place orders, or collect orders. And now in a lot of these situations, our users are typing things on their phone, but the typing things on their phone is secondary. What they're really trying to do is find their passenger or get their food. And so we're talking about busy people who are using phones, who are often typing a lot, but make no mistake, our users are not trying to write perfectly well-curated text. They're not trying to write like school essay papers. They're not trying to write Wikipedia articles. They're just trying to type the shortest thing that will be understood as quickly as possible. And so this is very different from the sort of text that standard NLP systems are trained on. We're used to training on things like Wikipedia data or newswire articles or translated corpora from parliamentary documents. And one of the things I think working with Southeast Asia has really taught me, and working with users with smartphones particularly, is that the smartphones thing is really important. It changes the way people write text. And the way we've been building NLP systems for years, even if we say we're very data-driven, if we're using Wikipedia and news articles, it would be like trying to build a speech recognition system based on the way people talk on stage when they've been practicing their lines for a particular part, for a play, for months. Not the way people actually talk in practice, in loud, noisy environments with a lot of disfluency, a lot of ums and ers and going backwards and repeating themselves and interruptions. And for decades, the speech recognition community has understood we've got to deal with scrappy, noisy speech. And those of us who've worked in the text community have missed that, and the smartphone revolution has really brought that to us in a very clear sense. We've got to be where users are, and users are writing short, meaningful, but not perfect not grammatically perfect text. They're just trying to get stuff done. All right, in Southeast Asia. So natural language processing for smartphone users in Southeast Asia. And I want to talk a little bit about Southeast Asia itself. It's, of course, where Grab works. So it's where most of the language processing work that I've done for the past 4 years has been really entirely based and entirely about. And Southeast Asia is one of the world's most dramatic and exciting regions at the moment. The technological transformation is rapid, it's very real. Things that I'd been told would happen, that people would use laptops without even having desktops or mainframes, that forget laptops, people have smartphones, and it's the first computer they might have had, used, and it might be the main kind of computer that they will ever use, because it might be all you need to get your job done. And so dramatic growth in the amount of text and language we're getting from Southeast Asia. But here's one of the problems with language processing in Southeast Asia, that the resources we have are comparatively lean or not very well developed compared to some of the traditional language resources for other parts of the world. So, for example, if you want documents accurately translated into more than one language, well, you've got Canadian parliamentary documents that have been in English and French for a long time, or a long period of Hong Kong documents that were in English and Chinese, or a lot of European Parliament documents or European laws that are in lots of different European languages. There isn't anything corresponding to that in Southeast Asia, as far as I'm aware. And so, to pick one quantitative example, if you can see the slide here, that numbers make some of these things more dramatic. That if we look at how many, so the number I picked to track was the number of Wikipedia articles, or actually the number of edits to Wikipedia articles. That's a little bit more reliable sometimes because there have been robots that have automatically translated Wikipedia articles, so the number of articles might not be very indicative. But the number of people editing articles, in English, okay, there were nearly 1 billion edits of Wikipedia articles, not surprising, but even in a much smaller European language, I picked Dutch as an example, over 50 million edits of Wikipedia articles for 21 million speakers. Now, so those are some of the world's most popular languages on the right-hand side for representation in Wikipedia. Over on the left-hand side, let's have a look. The most prevalent language in Southeast Asia, which is Malay, if you count Indonesian and Malaysian as part of the same language, has nearly 300 million people who speak it. And about a third as many Wikipedia edits as Dutch. And if you carry on looking down that table, the number of so the amount of active online available resources for language processing in Southeast Asia is a lot less than for Europe, for North America, for East Asia. And that's definitely a problem that we have to deal with. So the messages are very brief. The language resources are comparatively rare or sparse compared to other parts of the world. And even though we're talking about very brief language, Southeast Asia is also very multilingual. And so in North America, we tend to assume that if a system deals with English and Spanish, it deals with pretty much everyone who lives in North America. In Southeast Asia, you can't do that. Different countries have different languages, and different people within countries speak many different languages. And another thing we might not notice, especially from a North American or say British or indeed perhaps Chinese perspective, we shouldn't assume that users just speak one language. there are many parts of Southeast Asia, like a taxi driver in Kuala Lumpur in Malaysia, you can probably presume that they might speak at least Chinese, Malay, and English. In Penang, they'd be likely to speak Tamil as well. Many places are very multilingual, and many conversations are very multilingual. So I picked some examples here. These are a couple of the conversations that I saw and remembered when I was at Grab that I picked because they're very short, but even in the space of a few lines, you'll see, for example, in this top one, a driver writing in English, "Hi, please wait, I'm coming," gets a reply, "Okay, je, tak ada hala," which I think in Indonesian is very brief slang for, you know, "Okay, mate, no problem, I'm coming." And then there's a little emoticon in response. Or this next conversation, like, ni hao, and the driver is saying they're there. This is one of the comparatively few phrases in Chinese that I can remember and recognize immediately because it was one of the kind of automated Grab messages. So the driver says, "Hey, I'm here." The passenger replies in English, so the driver says, "Okay," and the driver replies in English. And that's something we saw a lot of in Singapore, and particularly in Kuala Lumpur, is drivers who are fluent in both English and Chinese. And this bottom message in Thai, the driver is even starting with effectively the same message stuck in traffic in Thai and in English. And then when the passenger writes back saying, "Okay," driver presumes, "Oh, all right, probably let's use English for this conversation," and proceeds in English. So that's some examples of the kind of text that we're processing at Grab. So let me pop out from those particular examples to some of the language challenge areas at Grab. So those were taken from GrabChat between drivers and passengers. And so GrabChat between drivers and passengers in a situation where people are trying to find one another, and quite often do speak different languages in Southeast Asia. This is one of the very interesting challenges that Grab has that Didi in China or Lyft or Uber in North America don't have so much. And I dare say there's many people on the call who can tell me more about the situation with Ola in India, which I'd love to hear more about, and I haven't actually worked with at all. And so in Southeast Asia, we're bringing people together who are comparatively likely to speak different languages. We have search products, destination search and food search. Food search was one of the things that Vaibhav and myself collaborated on for a short time. It was fun. And so language questions in food search, for example, technically chow mein written in Chinese, because that chow mein is just the English transliteration, and mee goreng, noodles fried, all mean the same thing, technically. In fact, the Indonesian word mee, as in noodles, is a direct borrowing from the Chinese mein. And I'll apologize for my bad pronunciations. And I'll just apologize once. You'll just have to put up with it for the rest of the talk. So they all literally mean the same, but do they really mean the same? If you see chow mein on a menu and mee goreng on a menu, you're actually likely to get slightly different dishes, because one's very Chinese style and one's Indonesian, very spicy chili style. Delicious, spicy chili. And so knowing what people are looking for, how they might describe it, and what it might actually map to on a menu is an important language processing challenge. This is also relevant for advertising. If someone looks for ravioli, then nearby Italian restaurant might not be satisfy the exact search query, but it's definitely a relevant ad. Language processing is important for customer service ticket understanding. This is more directly what I'm working on now at LivePerson. It's a very interesting set of challenges that when someone writes into customer service, they're normally trying to get something changed. What is the situation in that they're unhappy about? What's the situation they want to change it to? And other topics we could talk about include sentiment analysis for social media streams. Grab has a presence on Facebook groups that drivers can be part of and write into. There's a lot of messages. It will be really nice to get some automated summaries. Are people really happy today or unhappy today? And working on these things for Grab, particularly in Southeast Asia, I think one of my least favorite phrases became, well, that's not supported for Indonesian yet, or that's not supported for Bahasa yet, which is often the term used for Indonesian, well, Indonesian, Malaysian, the Malay languages generally. And so this definitely leaves us with an AI problem. On the one hand, there's often a lot of encouragement, almost orthodoxy, to say, well, you should do whatever, use whatever Microsoft or Google provides and it'll work well for you. Well, if they don't support the languages you need, or they don't support them very well, then what else are you going to do instead? Because when users are unhappy right now, can't find one another, something as simple and basic as that, well, maybe Google will have solved it by 2022. Yeah, that's not a good answer. So how should you approach problems like this? And so this is a slide of some rules of thumb for practical NLP. One of my first rules of thumb nowadays is actually, pun intended, most users are typing with thumbs. But apart from that particular rule of thumb, a very important thing to remember, what are your users saying? When we're dealing with text, it's not coming from the abstract web. It's not just text. It is coming from our users. And users type messages when they want to do something, and they are our customers, and it is our duty to serve them as best we can. That's a very different approach from a lot of academic machine learning, which says, well, it's the data. And I build machines that look at the data, and there's too much data for me to look at, so I have to get the machines to look at that. No. Machine learning should never be an excuse for not looking at the data yourself. You can't read it all, but you can read samples, especially when that data is coming from users who are complaining. But what if you don't know the language? Start learning it. I really mean that. We normally assume in tech that if we ask someone to learn, Python and they've only used Perl before, that's a reasonable request. If we ask them to start learning Indonesian and they've only spoken English and Chinese before, we just assume that, you can't ask that. People won't be able to do it. Yes, you can. There's tools to get started. Use Google or Bing Translate. Ask one of your friends who speaks the language. Just find a way of figuring it out. Don't say, I can't do it. What are your users saying? What are your users trying to do? And very much bear that in mind, because when we work inside tech companies, problems are often phrased to us some degrees abstract from the user. So, for example, why would you use translation? Well, because users are trying to communicate in different languages, and this is a difficult thing to do. Well, yes, in a sense, but that's a bad answer. Drivers and passengers are not really trying to communicate in different languages. They're just trying to find each other. That's the user-focused answer. And so long as you can make sure users have a way of finding each other, you've solved the user problem. Don't turn it into a harder problem, which you don't need to solve. Another rule of thumb, where do you get data from? Just go out and find it. There's Wikipedia, there's Newswire, there might be less for Southeast Asia, but even though I just described Southeast Asia as having comparatively little data, there's way more data for Indonesian than there was for English 20 years ago. So go and find some. And another big rule for NLP at the moment, do keep up with the field. There are a lot of things that are happening, but that's a means, not an end. Don't make using the latest, greatest model from Google or Facebook or Microsoft, oh, we have to use it because it came out with a great fanfare last week. If it helps your users or helps you to help your users more effectively, use it. Otherwise, just it's interesting, but you don't need to use it. All right. Let me go on to an example. This is, well, it's really several examples, but I'm going to try and pull together some of the things I've just been saying into like, how do we really go about doing NLP in practice? So this is the GrabChat translation example, which is after a driver and a passenger at Grab have been allocated to one another, then they can exchange messages directly within the app. Actually, interestingly, this was initially a feature that Grab did to save drivers from having to pay SMS data message fees. And then it became popular in itself. And then we had this situation where a lot of drivers and passengers, the most standard cross-lingual pairing at Grab being an Indonesian-speaking driver, English-speaking passenger. And so once they've been allocated to one another, the driver and the passenger often have to exchange messages to try and find one another, but they might not write in the same language. And so, simple answer to this, by 2017, we already had plenty of news articles saying machine translation is a solved problem. Like a little bit of a soapbox about that. I don't like articles like that. We have one experiment where a NLP system does a job of translating English news articles, well-written, well-curated text into Chinese, and several annotators say it's as good as a person translating it. And before you know, the tech press has gone bananas saying computers translate human language as well as humans do. Now, in that one experiment. And so there was this presumption, if we use Google Translate, this problem will go away. It didn't go away at all. We got some of the messages right. We got a lot of the messages wrong. And here's why. Examples, if you're trying to say, where are you, sir? If you're trying to say, where are you in Indonesian, your most normal way of saying it is di mana. Di mana just means where. But if you put a suffix on the end, term of address, di mana bapak means, where are you, sir? The corresponding would be di mana ibu, which means, where are you, madam? So to begin with, drivers don't type that. They type DMN pack, because who needs vowels, really? You know, you're trying to type with one finger, and you know that most passengers just understand this. So why would this passenger be different? So the problem was a few years ago, Google Translate didn't recognize that at all. Even if they typed perfectly di mana bapak, bapak and ibu literally mean father and mother. But they also mean sir and madam as polite terms of address. You can think of this in English that father is a polite term of address for a Catholic priest, for example, or an abbot. It's an ecclesiastical church term of address. But the chances that the person you're about to pick up is a Catholic priest are relatively small. The chances that the person you're about to pick up is your own father are vanishingly small, because if it was your own father, he'd probably have just called you and asked for a ride. So in general language, we have to distinguish, there's an ambiguity problem here. Does bapak mean father or sir? Does ibu mean mother or madam? But in our context, we know that the driver and the passenger are only having this conversation to begin with because they've been put together by the allocation system. So father isn't the appropriate translation and sir is. So that led us to some obvious observations. First of all, let's go back to look at the messages we're getting, because the messages we're going to be getting are going to be different from what Google Translate is trained on. And one of the first fun things I noticed looking at these sorts of data sets was OK, just that string OK, is the most common message in not just in English or in Singapore, in every country in Southeast Asia, even Thailand. So it's just international slang. So for a message as short as that, you don't even need to decide which language it's in, because it's the same in all languages. And the corollary of that is you don't need to translate it. Now, where that's interesting at the moment in natural language processing, I said at the beginning, rule-based methods, were popular up until the 1990s, but they're not popular now because they don't scale. Well, they don't scale to everything, but if one rule will get you 25% of your data, you'd be a bit stubborn not to use it. So in the mixture of really production systems tend to be rule-based and data-driven machine learned, this is a good example. Just translate OK as OK, always. Don't try and do language detection. On the topic of rules not scaling, about 50 common words was more than half of the GrabChat messages. 50 to 100, depending on which language we were dealing with. Now, why is that? Well, it's because most of the corpus is just people trying to find one another. So if we could solve that problem, we can solve most of the problem. So we're not dealing with a big, long tail of complicated language. We're dealing with a small header distribution with very simple language. Most words are used unambiguously. So I dwelt on the example of Ibu and father. Don't need to worry about them being technically ambiguous because in this context, they're not. The problem we do have on smartphones is any number of mistypings and misspellings. And so that was the problem that we had to try and solve. The thing is, misspellings are often quite predictable. In Indonesian, it's very normal for people typing to leave out vowels. In Vietnamese, it's very normal for them to leave out diacritics. I'll come to what those are in a short while. So the kind of errors people make are predictable. So what can we do about this? Well, we weren't going to build a machine translation system from scratch because we weren't going to do better than Google Translate. And it was seen to be not the big problem. So a relatively quick sample showed that the problem wasn't translating grammatically dictionary correct Indonesian into English. The problem was translating smartphone Indonesian into technically correct schoolroom Indonesian. I don't even know really what to call it. I don't like saying incorrect and correct because it's what people type. If that's what people are typing, that's what you use as a word. The customer is always right. There's no point telling people, well, you typed it wrong, so tough luck. It's what people write to each other, so we should understand it. So instead of trying to translate Indonesian into English, the problem we had was translating Indonesian abbreviated slang into Indonesian that Google Translate would understand. So we had to try and correct the Indonesian, but it wasn't really incorrect, it was brief. So my first instinct was, oh, well, let's use a spelling correction model. And I'll freely admit that first instinct was wrong, because the more I looked into spell correction models, they tend to focus on mistakes people make when they are trying to spell something according to the dictionary spelling. So that, spelling correction models tend to focus on transpositions instead of their T-H-E-R-E, T-H-E-E-R, or something like that. You just swapped a couple of the letters around. Or substitutions. You were meant to type an A and you typed an S next to it because it's right next to it on the keyboard. Those are spelling errors. Typing pack instead of bapak is not a spelling error. It's just a different version of the same word, a shorter version. And so how did we address this problem? And this is one of the places where I could go into detail for some hours, but we don't have some hours. So that's so what we used was a combination of so-called orthographic similarity, not in the Levenstein edit distance sense that you lose points for every letter that doesn't match, but in a sense that you gain points for any letter that does match somewhere along the string. So this is the semvec-pi semantic vectors orthographic similarity, which I'm very familiar with because it was well, beating around the bush. I wrote it some years ago, back in 2008. I didn't invent it, I just did the implementation. And instead of saying the distance between BPK and BAPAC is 2 letters, and that's the same as the difference between AA and BB. We say, oh, well, there's a B at the beginning, a P in the middle, a K at the end, and 2 things that are unaccounted for. But hey, the B, the P, and the K, they match, and they're at the beginning, middle, and end. And we had a system for expressing that in terms of symbolic computations on vectors that we originally invented for comparing the overlap of gene sequences that worked very well for some of these spelling correction things or these spelling similarity detections. It worked particularly well for these 2 strings are similar except for some vowels got left out, no big deal. And surprisingly for this problem, it actually worked better than fast text from Facebook, which is the shallow neural network implementation that came out in 2013. So this was trained on a kind of mapping between GrabChat and Wikipedia data. We also used the frequency of a word in Wikipedia to say, hey, which of these words is it most likely to be? So if you have DMN, domain might be an English match just on the consonants. Dimana is also a match on the consonants. And you can look at Wikipedia and say, okay, which of these is more likely in Indonesian? Dimana, by a long way. So this allowed us to create a mapping dictionary, say Bu to Ibu, Pak to Bapak, SDH to Sudah already, lots of little words like that. And then I'll mention, as soon as we say language, people tend to think big data. A lot of language is big data. In this case, we only had 100 common words to cover. And even with on average, about 30 typical abbreviations per word, we only have 3,000 word mappings. So, you know, I'm not going to ask anyone to raise their hand online and say, oh, how, you know, can you fit that in memory in a hash table? Yes, you can. So the production implementation of this wasn't, you know, it's not TensorFlow serving or some, you know, big data heavy Docker Kubernetes deployment, however good those things have become, and they are good when you need them. This thing could be deployed just as a JSON file with 3,000 A to B mappings, gets written out from Python, read in Go, no interlanguage support problems, and it's just a dictionary and memory runs like lightning. We're talking about microseconds, not milliseconds, no problem at all. So another of my little tips for NLP in the field is we tend to think of natural language processing systems as being relatively big, heavyweight. They aren't always, and sometimes their memory and speed requirements can be tiny and they can be really, really fast. If something's simple, keep it simple. You get performance benefits from that. Okay, I'm about halfway through the talk, so let me pause and see if there are any questions. Stop screen sharing for a second just to see if that are. And sorry, Carol or Vibav, could you please share? Oh, we have a question in the chat bot. Okay, is chatbot at Grab powered by Azure services? For multilingual notification, is there any limitation when it's a lesser known used language? Yes, absolutely. I don't know exactly where we are with chatbots at Grab at the moment. I do know that we tried a couple of things with the help desk for Indonesian a couple of years ago, and here's one of the problems was that support for Indonesian wasn't very good at the time. I really do hope it's got better. Another of the problems, though, was the sort of personalization level of chatbots. So what we also found was where the chatbot was successful, it was doing things that weren't very hard to begin with, such as sending someone to the right help desk article. But what it couldn't do was some of the more personalized things, like, say, oh, the driver didn't pick you up. Here, tell me your booking code. I'll look that up. Oh, yeah. We've got a problem here. I need to give you a refund. I'm going to give you. And building a chatbot that can understand some customer intents, even in a relatively unsupported language like Indonesian, looked like the bigger problem. But a chatbot that can understand the customer intent and a chatbot that can solve the customer problem are two very different things. And yeah, one of my personal reservations about chatbots is until we trust them enough to actually make financial decisions, like I have looked at this case in enough detail, and like this chatbot is authorized to give refunds, then there's only so much you can do with chatbots that really solve problems. So this is definitely something I'm going to be fascinated with at LivePerson. To what extent, when we're really depending on chatbots, how much do we really trust them to like go as far as suspending accounts or spending money? Okay, let me go back to the talk. So I walked through that translation example in some detail. What I want to do for the second part of the talk, which will be somewhat quicker actually, is just go through some of the languages we're dealing with in Southeast Asia and some of the things that were easy and difficult about them. So I'm going to go back to sharing my screen, and here we go.
Hey, Dominic,
yeah.
do you mind one more question from Rachel here?
Oh, yeah. Delighted, yeah. Oh, yeah, I've just seen it, sorry. When coming up with the mapping dictionary using positional, orthographic similarity and distributional similarity, what context or sentence is used in the training, right, or was individual words enough? That's a really good question. We found that a combination of the two was best. And so the orthographic similarity based just on which letters appear in the word, that is without any context. That is just a set of mathematical rules for how do you turn a collection of symbols into a representative vector. And one of the things I was surprised about that is that the purely mathematical symbolic way of doing it using the Sembec Pi implementation actually did better than the trained on character engrams way in fast text. So that's another story. But then the distributional similarity we used was a combination of Grab messages and Wikipedia. So, and even then, I tried training it on GrabChat messages, and that didn't work very well because you've seen how many of them are really, really short. They're still, messages like okay. What I trained that on in the end was Grab reviews messages, which have they're somewhere in between the very ad hoc okay messages and formally curated Wikipedia or something. A user who takes the trouble to write a review on a phone has something they want to say, normally more than a couple of sentences, but they're still typing on a phone. It's still relatively colloquial. So reviews data I found to be relatively representative of how users would type on smartphones if they were typing longer messages. So it was more applicable than Wikipedia to the GrabChat case. And then for the question of what will Google Translate recognize better? Well, Google Translate was definitely trained on things that are more like Wikipedia articles. So what I ended up using was a word embedding model built from Grab reviews data, but the target frequency data from Wikipedia. All right. Okay, let me go back to screen sharing, or am I already screen sharing again? Can you see my screen? Someone please type play
Thank you,
out.
Dominic, for
All right.
answering the question. Yes.
Right, thank you. All right. All right. So I'm going to do a quick.
We couldn't see your screen.
Oh, sorry.
We cannot see it yet.
You cannot. All right. Let me try again.
There you go.
There you go. Thank you. Thank you for watching my back there. I do appreciate it. Right. So I'm going to do a quick tour of the main languages we're dealing with. I know we're somewhat short of time, and I do want to leave time for questions and discussions. So I keep right. There we go. All right. So I've talked a fair bit about Indonesian. Indonesian and Malaysian and the general term Bahasa, they're all variants of the original Malay language, which is at least a good 2,000 years old and is spread throughout the archipelago, the big collection of islands, and the mainland Malayan Peninsula. Are they different dialects or different languages? It's really not for me to say at all. What I can say is that's a really interesting question. They're mutually intelligible. Normally, someone from Malaysia who speaks Malaysian can get by in Indonesian, like just as well as I could get by in American English when I first moved here. There's certainly parts of the world I'd hope, if I there's probably more differences between American English and Jamaican English than there are between British and American English, for example. The ISO standard says that MS is Malay, ID is Indonesian, ZSM is Malaysian, but generally we use that to mean Malaysian Malay. So it is confusing, and it's partly historical. And the main thing I've noticed or been told is that, quite like British and American English, if I've learned Indonesian, I can get by trying to use it in parts of Malaysia, but I might badly embarrass myself, or I might say something that is kind of regarded as rude, or like some Indonesian words like saya mau for I want should be saya ingin in Malaysia, and other things I was just taught of, yeah, you can get by, but don't say such and such. I say languages with a very rich history, and like most parts of the world, the written alphabet is borrowed from other parts of or other previous languages that were written previously. So written originally using a version of one of the many Devanagari scripts from the Pali canon of Buddhist scripture. Later written using Arabic after a lot of conversions to Islam from the 13th century onwards, and a lot of scholarship and sharing with other Arabic speaking and writing communities over the Indian Ocean. But for a century or more, nowadays Indonesian is mainly written with the Latin alphabet. And one of the lovely things about that is adaptation to the Latin alphabet was done sensibly, unlike English, which is a mess. So the spelling and pronunciation really makes sense. So for example, the word for cancel, it's not the official word for cancel, which I think is betul, but the way cancel is often written is very obviously cancel. And as soon as you see that, you say, but that's not cancel, you haven't spelled it right. Oh yeah, they've spelled it right. And then you realize, I think we probably spell it wrong in English. So the C in Indonesian is a ch sound always, and the K is a hard k sound. So the way we write cancel in English would be chancel, pronounced in Indonesian. And as soon as you look at it that way, you realize, yeah, the C is being used as a K at the beginning. Anyway, I like Indonesian spelling, and it reminds me how much I dislike English spelling. Indonesian spelling with the Latin alphabet was designed. English wasn't. Long story there. Now, the way it's typed on smartphones, very colloquial, lots of slang. And I used to presume this was because autocorrect doesn't work very well. The more people I've talked to in Jakarta have said, oh, no, what autocorrect is on our phones, we just turn it on straight away because it just sounds wrong. It makes me sound like I'm, trying to pass a school exam or something. It's just not the way we like to talk. So that's a real kind of technology user mismatch that I didn't know about. Filipino or Tagalog, I haven't worked on a great deal. It's an Austronesian language like Malay or Polynesian, Hawaiian, even Malagasy all the way across the Indian Ocean in Madagascar. Like Indonesian, the idea of a Filipino language is related to nationhood and developed particularly by nationalist, like independence groups from the 1930s onwards. Filipino's official is kind of official Tagalog, like Indonesian is sort of official Malay, but there's several other languages at least as prevalent, like Cebuano. And so in Manila, at least, English seems to be the main language of commerce and technology. This is really answering the question that nobody asked yet, but why did Grab particularly not do so much in Tagalog or Filipino? Like the driver app was never even translated into Tagalog. I don't know if it has been yet. And it's because English is so common in the Philippines. Right. Vietnamese. Now, Vietnamese is part of the Austroasian group of languages, which is different from the Austronesian group, like continental and island. Then that group of languages also includes Khmer, but they're written very differently. Vietnamese is written using Quoc Ngu, which means national language. In previous times in its history, it's been written in Chinese characters, and that the Quoc Ngu is an adaptation of the Latin alphabet that has extra vowels and diacritics and tone marks, because unlike most of the other Austroasian languages, including Khmer and Mon, that Vietnamese has different tones, which again, scholars say are because of its particular large contact with Chinese for over 1,000 years. Interesting things about Vietnamese, white space tends to be syllable boundaries, not word boundaries. So if you're using a Vietnamese tokenizer, it will remove spaces in between characters rather than adding spaces. And I mentioned that there's a lot of vowels and these diacritic marks, accent marks that are vowel changes and tone marks. And guess what? When people are typing on mobile phones, that's the first thing they leave off, especially when they're typing in search queries. This leads to the challenge of so-called diacritic restoration in Vietnamese, which is interesting from a language point of view because it's a sort of pure disambiguation challenge. There is one of the correct accents that people meant to apply, and most disambiguation challenges aren't like that. If someone says, I went to the bank, do they mean they went to the building or the financial institution? Well, actually, in that context, it's both. So it's not a kind of pure only this or that ambiguity. Whereas Vietnamese diacritic restoration, if you want a pure ambiguity challenge that's from real life, not just an artificial one, pick Vietnamese diacritic restoration. Lots of open space there. One of the rules that came was for search queries, since people tend not to bother with the diacritics at search queries, you need to make sure, if building a search engine that's going to process Vietnamese documents, that queries without diacritics can be mapped to documents that did include diacritics, but not vice versa. Thai. I don't have much time left to talk about Thai. That may be a relief because Thai's hard. But, well, when I say Thai's hard, of course, languages aren't easy and hard. They're familiar and unfamiliar. And Thai, of all the languages I worked with at Grab, it was the least familiar to me because it's a completely different character set. It is one of the character sets also derived from the Devanagari family of character sets. So So the people on the call who are familiar with languages in India, or at least several of the languages, will at least have more familiarity with this family of alphabets than I did when I was starting. And so the Thai alphabet's derived from the Brahmic style of writing, and particularly the Pallava alphabet, much of which is to do with the way that Buddhist scriptures came into the Khmer Empire from about the 5th century onwards, and then the Thai peoples migrated south in around the 12th or 13th century. And so along with the Korean alphabet, the Thai alphabet is explicitly attributed to a great king, and so the king, Ramkhan King, is meant to have designed the alphabet, and each consonant is an onset sound and with a tone. And if you want to change the tone, there are particular tone marks. And so Thai is meant to be the first alphabet that came with, was designed with tone marks. The vowels, they go around consonants. And you might have a vowel before the consonant, you might have one after, you might have a combination of before and after that between them make a vowel sound. And I have to say, the first time I read about this, I thought that's crazy. And then it reminded me, oh, we do that in English as well. So for example, the way we write cake in English is just like some of the vowels in Thai. There's a letter before and a letter after, and the E after the K tells you what sounds the A makes. It's actually rather baffling. And Thai was written without spaces in between. So Thai tokenization involves putting the spaces back in, which is often done largely combinatorically, that I've just described, well, there's a consonant and vowels around it. So you can tell by the time you've got to the next consonant, you've got to the next syllable, and you can sort of take it from there. Another fascinating thing about Thai is the so-called polite particles that I don't know of any corresponding thing in other languages. But as a male speaker, to say thank you, I would say "Khao kun." But to say thank you particularly politely, I would say "Khao kun krat." And as a female speaker, the corresponding thing to say would be "Khao kun ka." And so they're very commonly used words for politeness, and they're virtually untranslatable in English. You can't say "Good morning," and I'm trying to be polite to you, and by the way, I'm a male speaker. Nothing translates that. But basically, you're at the end of an utterance, and depending on your gender, you add a particle. If you're trying to be particularly polite, but I was definitely advised, don't say it always because you might sound like a computer. So that's fascinating. And one of the generalizations, and I want to just about finish with, is one of the big generalizations I found for working with a range of Southeast Asian languages is that age and gender are really important sometimes when describing yourself, and very often when addressing other people. And now this is an interesting generalization because they're not all languages from the same language family. I've already mentioned the Austronesian family, the Austroasian family. There's the Kradai family, of which Thai and Lao come, and they are distantly related to the Chinese family of languages from which the Thai and Lao people were migrating south this 800 years ago or so. Burmese, or the Myanmar language, is more closely related to Chinese. But anyway, different language families. But surprisingly, most very systematically vary how you address someone, and sometimes how you address yourself, based on gender and age. So the corresponding thing would be third person in English. When we're talking about someone, then if we're talking about an object, it's it. If we're talking about a person, we should know their gender to know whether you're saying you should say he or she. So that's a gender pronoun distinction that English makes. It's not, most European languages make that distinction, il or elle in French, etc. Though Spanish, usted gets rid of it in the sort of formal, polite third person. It means something like, you know, your worship or your excellency, which wouldn't vary with gender. Chinese just has ni, which ta for third person, which doesn't vary with gender. But that's given several examples that don't vary with gender. The surprising thing for, I think, European languages and maybe Chinese speakers as well, is that, for example, in Indonesian, if you're addressing someone, you will very often refer to them as Pak or Bu. For example, in English, if I were to say to you, if I was a waiter serving you a drink and I said, would sir like a drink? That would be really formal English, let alone talking to friends. But if in Indonesian, I were to ask, Bapak mau minum, would sir like a drink? That would be a totally normal way of saying it. And if I were to ask instead, like, yeah, anda mau minum, that might be less polite. So the sirs or madams, when you're addressing someone, are important in Indonesian. They're even more important in Vietnamese, where they're also kinship terms that vary both with gender and with age. So to say thank you to a older woman, that would be kamomba, whereas to a younger woman, or maybe someone my own age, that would be kamonji. And Thai, we just went through how it behaves in the first person changes. So the generalization I'd like you to take from this is that, you know, everyone's used to third person pronouns changing in English. Just imagine that there are languages, and there may be many more outside Southeast Asia that I'm not familiar with, but imagine languages where the I and the you, the first and second person, also change with gender. Then think for a minute, how are you going to do that with a machine learned system? Because another thing about Wikipedia and Newswire articles is they're all written in the third person. The amount of there's a lot of the, that, he, she, it in Wikipedia, and there's very little I and you, because it's not conversations between people. So A, you're going to get a lot less of that data in Wikipedia, and B, no amount of training data is going to tell you whether you are speaking to a man or a woman, or a young person or an old person right now. And this is one of the naiveties that we've had in sort of machine learning and deep learning for natural language processing, that if we give it more data, eventually with more data, more graphics processing units, more processing power, any problem will eventually be solved. No, it won't, because no amount of training data will tell you if you're speaking to a man or a woman right now. So again, for me, that comes back to the principle, who's the user and what are they trying to do? And all right, so yeah, this is repeating that. It's genuinely important for natural language generation. If I'm designing a chat bot that's going to address a customer directly, what am I going to call the person? Like, what is your name? Even asking that, you could get it wrong in some languages because you're using the wrong word for your. So how might we figure that out? Well, obviously, no amount of training data that isn't about this particular person will tell you. Training data that is about this particular person will have privacy issues attached to it. You have to be very careful to trade off how are you really serving the user? Don't compromise their privacy just to be polite to them, but don't be impolite. How are we going to figure this out? Really interesting challenges at the intersection of language, user, and data. All right. Another question, what language should we use anyway? In North America, you can presume that if someone's phone is set to English, they're an English speaker. You can't presume, well, you can presume that in Southeast Asia, and you would often be wrong, because we have the user's device language setting, but it's not necessarily the language they're most likely to engage in. Particularly in Malaysia and Philippines, we have a lot of phones set to English, when you actually look at the GrabChat messages from those phones, they're often in Tagalog or Malay. People might write reviews in English and tweets in Tagalog. Different registers between formal and informal language have people switching languages. And in particular obvious cases are the poorly supported languages like Cambodia. More than 90% of people in Cambodia speak Khmer, but most phones were set to English. Why is that? Because people prefer English, and probably because their phones work better in English. This is a chicken and egg problem. It is tempting and easy for people to say, look, English works fine, and they're minority languages, they're just not terribly important. The thing I like to say from that is, if we'd had the same attitude 500 years ago, we'd never have started translating books from Latin into English and French and Spanish, because everyone who read in Latin. Well, that might have been an argument 500 years ago. I'm very, very glad that people didn't stick to it. All right, I'm going to finish, and genuinely finish this time, with just a few funny examples that I remember, just because language work can be entertaining. These are translations. So we got this translation, I'm waiting for the red flame to extinguish. This was from Thailand. It turned out this word, next word down, fideng. Oh, trying to scroll over it, moved it. Fideng means red light or red flame. If you use the word red torch in English, that might be similarly ambiguous. So this driver was not saying, I'm waiting for the red flame to extinguish. They were saying, I'm waiting for the light to change. In Vietnamese, this word roi, technique means rod or whip. And we got this complaint saying, the driver said he was going to whip me. Or like, what's this whip thing? It's a diacritics thing. Roi on its own, without diacritics, is a very rare word, meaning whip or rod. But with the diacritic marks, roi, downward tone, means already. So toiroi means I'm here, I'm already here. But it got translated as I whip. Okay. Yeah, I am young crispy. Crispy apparently is a term that people use for foods to describe crispy food in Indonesian. Ayam means chicken, and chicken, this user was just trying to say, I want crispy chicken. It can be translated as rooster or cockerel, and the diminutive for cockerel is cock. I'm going to leave it to your imagination what the translation error was there, and I'm just going to say we fixed it. And thankfully these mistakes, I went back and checked them just before this talk, they're actually mainly fixed in Google Translate right now. Anytime I've given a talk that says Google Translate gets this wrong, I've learned from experience I should always say Google Translate used to get this wrong, go back and check it, because they are constantly making improvements, and however many drawbacks I've seen with it, I use it the whole time. Anyway, the other thing I'll finish with is watch out, because if you're the NLP engineer, you're still responsible for this. The user the message showed up in front of the user was confused, maybe even offended, and whatever systems we plug together, we're still responsible for the output. So that, with great excitement comes great responsibility. Don't ever just plug systems together and say, well, I read the precision and recall scores and they seem pretty good. Like, you're responsible for the data because you're responsible to the users. So if this all sounds like great fun, how could you get involved? Well, to begin with, I would say learn some of the other languages really seriously. Choose a modality you'll stick to. Some people use apps, some audiobooks, some like to go to classes. Duolingo, terrific app, has Indonesian now and Vietnamese and Thai, I think. Do play around with Wikipedia data. I've said it's not necessarily that representative, but you can certainly play with it, build interesting models with semantic vectors or fast text. There's an increasing number of multilingual models available. If you want more down where the users are data, try and sign up for a Twitter API developer account, and that will get you stuff people typed on their phones. So I'll finish with saying, thank you, or terima kasih, Punkrap, thank you, Xia, Kamon Barn. I can get away with Kamon Barn. I think Barn means something like mate or just friend. So I'm not calling you either male or female. I'm just saying, thanks a lot, mate. Arun Sostai is Khmer. Salamat is one of the ways of saying thank you in Tagalog. Anyway, thank you ever so much for coming. If you want, that's a picture of the front cover of my book, Geometry and Meaning, that's 15 years old now, but it's still a fun read, and a lot of it has stood the test of time. So if you were interested in, particularly in some of the vector stuff and how I've used it, that's still available. And I know I've run over the time for which I was supposed to be talking, but hey, we started a little bit late, so I'm gonna stop sharing right now, and having said a big thank you to you all for coming, and then a particular thank you again to the organizers for setting this up. Any other questions, I'd be delighted to try and answer them.
Thank you, Dominic, for sharing such an insightful session. I think we do have a couple of questions in our chat box.
Okay, thank you. Right, let's have a look. Thoughts on sentiment analysis. I can see that in chats and so in social media. Yeah, really interesting question. We worked a bit on sentiment analysis. Well, a fair bit actually, because so my main thought on it is you need training data, and so where are you going to get it from? And our training data at Grab, the main things that we had were reviews. They're the things that, rate your ride when you're finished, give it 1 to 5 stars, and then the thing you discover quite quickly from that is that people go to the effort of writing a review telling their sentiment when they're either particularly happy or particularly sad. So a lot of training data for sentiment analysis is you don't get very much lukewarm, yeah, it was fine. You either get that was great or that was terrible. And the interesting thing, so we tried training a sentiment model for that. I'll just tell a brief story about this. And it did a very good job of predicting the star ratings on the sort of held out data of, like, let's pretend we trained on January, February, March, and lost all the star ratings for April. Did a very good job, over 90% precision, about 95 in some countries, of correctly predicting sentiment on other things like that. So then we tried using it for tweets as well. Like, let's pretend that a tweet is just a review. And then we discovered that, here was the generalization. It did very well. A 5-star was still a 5-star. If someone was saying something very positive, it could really recognize that. It did a much less reliable job at detecting negative sentiment. And so what I learned from that is, if people want to say something is good, there's a relatively small number of ways of saying that. If someone wants to say something was bad, boy, there's a lot of creative ways of saying that. So whether it was, the car is this, the driver was that, they're all predicates that if someone is then describing their experience with Grab customer service, or going to watch a movie, or the food they got, they might be quite different words. So I think it is easier to recognize positive sentiment than negative sentiment. And that's actually bad news, because we normally really want to recognize and fix negative sentiment. So that's definitely a challenge. Okay. I started with the shortest question. I'll go on to the second shortest. Looks like it's similar to South Asia, English for business, native language, and personal life. That's really interesting. So yeah, that is something I've seen particularly in Philippines, Malaysia, Singapore. Of course, we think of Singapore as a English-speaking country because of the education system, of course, but like more than half the people in Singapore speak other languages, principally Chinese, in the home. So yeah, it is similar, and there are pros and cons to that, definitely. So let me longest question at the bottom. It is not possible to use label data from profile to supplement such translated so do you, right, yeah, very good question. So if a user, yeah, thank you very much for that question, Rachel. So there are some rules of engagement. If the user has explicitly told us their gender by voluntarily filling in a survey, which we normally do for this sort of know your customer kind of things, then that's fine. If there's a conversation between a driver and a passenger, then we'll often see the driver picking Ibu or Bapak, sir or madam, and why or how they do that is often interesting. We've sometimes asked in interviews, the most common one is people go by the name or go by the picture, if there's a picture. But for drivers, there's always a picture. For passengers, not necessarily. So the name is your best bet. But names aren't an entirely good indicator of gender, and so partly because sometimes the user hasn't actually given their name. Our most prevalent name at Grab was sometimes iPhone in some locales, which obviously is not someone's name. So it very much depends on, let's say, things like how much interaction have you had with this user before? Have they given permission? Have they explicitly told you the data? It depends if it's part of the business arrangement as well. So this for Grab was different between drivers and passengers. You're not allowed to sign up to be a Grab driver without disclosing your gender, because it's typically on a driver's license, and you have to use your driver's license to sign up. Just like you can't, we have to know your, name, address, date of birth for a driver. We don't have to know that for a passenger. So a lot of reasoning around that is to do with what's responsible use of data. So that does segue nicely into the next question from Harsha. Any experience I want to share on bias by AI systems? You know how I just mentioned, we always know the gender for drivers. It should follow that you could use knowing the driver's name and gender as training data for inferring a passenger's gender from their name. And normally, if we were all in the room together, I'd ask, does anyone want to hazard a guess why that won't work? So that I've tried that a couple of times in online meetings, and it doesn't work too well because people have to fiddle with their microphones and so on. So at the risk of giving a spoiler, I'll tell you immediately that the reason that works badly is because Grab's split between gender balance between passengers is relatively even, 50-50. Gender split between drivers, not at all. More than 90% of Grab drivers are male. So using all the driver training data as for gender prediction from name, naively done, would tell you not the person with this name is female or male. They'll just tell you most people are male, which is a really, really bad sample. Needless to say, we kind of more than half expected that, and it was not an experiment that was taken very, very seriously. But that was definitely one obvious example to avoid. Are there systematic reasons why the population from which you're sampling is biased? And that would have been one of them. Yeah. Anything else anyone would like to ask right now?
Is there any more questions, folks? Okay, then I guess that's all. Thank you again, Dominic, for sharing this insightful sessions on NLP. And I want to thank you everyone who joined us today. So just before we end this meeting, could I ask everyone to open your cameras, and we would just take a big screenshot of group photos together.
Carol, there seems to be another final question by Harry.
Oh, okay, one quick. Oh, I see it. What's the biggest pain point for providing more general NLP solutions to Southeast Asia? That's a really good one. I'd speak, I would say the single biggest answer I'd give is the context of use rather than the languages themselves. So if I was going to pick one word, it's noise. That increasingly we're looking at situations where people are trying to communicate and use their smartphones in noisy environments. This might be less of a challenge with social distancing right now. And so that, I think, is an even bigger problem than comparative lack of training data and so on, is that the ways we build language models traditionally for English and French and German and Chinese and Japanese, they're not just not very relevant to Southeast Asia, they're not as relevant to today. And that is something that particularly the text processing community really needs to tackle head on. Cool. Yeah, and yeah, I'm happy to take other questions offline. You can certainly find out how to get in touch with me, and anyone who wants to, please, keep in touch. I'm not working directly with Southeast Asia right now. I hope to again, and still will always regard myself as an ally of the region. So delighted to answer any questions or about language processing in general. So thank you all for coming again, and thank you particularly to Carol and Viva for organising this.
Thank you, Dominic. Hi, everyone. Could you open your camera for just 1 minute? Let's take a group selfie together. Hi, Divya. Hello, guys. We have a couple more folks here. Can we get more people to turn on their videos? Let's take a quick screenshot of everyone. Thank you. Can I get more? Hello, guys. Okay, without further ado, let me just take a selfie. Okay, thank you, guys. So that's our meeting today. Thank you, everyone, for joining. Have a nice weekend. Okay, bye-bye.
Bye-bye.